Hi, and welcome to the latest edition of ITAD in 15. This is actually a re-record of a previous session about the dirty secrets of media sanitization, because the quality on the live recording wasn't good enough. So we've taken the opportunity to record it for you once again. So I am joined again from Roger from EPS. Welcome, Roger.
Thanks for having me, Steve.
So Roger, for those of you who may be unfamiliar with EPS, what's the P stand for, please?
The P stands for protocol. We've been a protocol engineering company since 1999, myself since 1993 as a protocol storage engineer. Essentially, we code at the protocol level for everything we touch. So whether it's SCSI for SAS and legacy fiber channel, or SATA for all the different SATA storage medium out there, or NVMe for the NVMe storage media, even for network protocol. We actually wrote our own DHCP and TFTP protocol layers, as well as for serial ports for network switch erasure. We actually have our own read and write commands to the serial port at that level of protocol that we've written, just so that we can communicate directly with switches.
So for those of us who are not as technical as yourself, when we're talking about media sanitization, what's the importance of these protocols?
Well, I mean, each protocol has commands that are defined for different storage devices. Now, in the legacy world, it would have been just overwrites. So we're just doing writes of the entire media, followed by reads to make sure that it was erased correctly, and we'd move on. Then NIST discovered that, the old way of doing things, the DoD 3Xs, 5Xs, 7Xs, or even the crazy 21X overwrites was no longer necessary based on the media densities that were coming out, the more modern densities of storage media. And then the call for new commands came out to make sanitization more effective, quicker, and take it out of the hands of just software. So in other words, when SSDs were invented, they needed a way, because memory is one of those nice things that can be erased very, very quickly. They needed a way to be able to do that, so they invented the secure erase command. Now, that obviously fell flat on its face for reasons we'll be discussing down the road, but the reasons were that you now had memory manufacturers making hard drives and hard drive manufacturers making memory devices. And so there was bound to be all sorts of problems, because those two things, don't necessarily go together at that time. It was the first rough introduction of those two technologies. And so that led to a lot of firmware issues. So secure erase was abandoned because all these different companies were trying to write firmware, and data security was not at the top of their mind. It was, can I get this memory to store data like a hard drive? Can I make it addressable and accessible like a hard drive? And for hard drive companies, can I take all the technology I have from spinning media and put it into a memory-based solution? How do I address the memory? So those things were the real big growing pains, and things like data security and secure erase were left by the wayside. They weren't as prevalent or at the forefront.
So let me get this right. So we're talking about the firmware on storage media having features, if you like, which can be enacted by some software to say, please do this. And some of those features are being used by sanitization tool sets.
Right.
You mentioned secure erase being abandoned is the word I think you said. Is that because it was vulnerable as a technique?
It's because of the implementation of firmware. So anything that we send, so the modern data sanitization commands, for example, the sanitize spec, which has cryptographic erasure, has block erase. Those would both be for SSDs, NVMEs, depending on the support. Then there's block overwrite, which would be for hard drives, and cryptographic, which would be for hard drives. Then NVMe has its own command set. It has NVMe format, which also has a secure erase element to it, which is not the traditional secure erase, of course. And it has a cryptographic version of it as well. And so there's all these different commands that exist, and depending on how much importance a storage company places on it, that determines whether or not the efficacy is there. So have they gone through and done the command, made sure that not only the user space is gone, but the wear level space is gone on SSDs or NVMEs? Have they made sure that the bad blocks that they've marked as bad also get erased as well? So, these are the things that we trust storage media to actually handle when we send a command.
And is this where the session's titled "Dirty Secrets"? And is this one of the dirty secrets that we are reliant on the behavior of the firmware on the device to behave in the way it's designed to? And let's be realistic. I mean, we do testing. You've got your own R&D lab. Firmware generally behaves in the correct way, I think. Otherwise, we'd be raising the red flag. Is this an issue that we should be really raising its profile, or are we sort of being very weedy in terms of our expectation on firmware?
Well, I mean, certain things you should absolutely have high expectations of, right? So if I issue a sanitized cryptographic erasure or block erase on any kind of SSD or NVMe, I'm expecting it to do what it said it did, because the reality is it's protecting your data, my data, everyone's data. And if it's not functioning exactly as expected, and it can be, susceptible to any kind of attacks, then we're we're living on a false premise of security, where we think something's happening, but we don't know.
And do the manufacturers have to go through verification before these come out of the factory, or?
I wish. I mean, when it comes to unfortunate when firmware mishaps, if you will, I mean, people are human, and so firmware designers are human, coders are human. They make mistakes. Software is obviously fallible, and we depend on certain checks and balances, right? And reliability demonstration testing. We depend on quality assurance testing and protocol level testing. And if all of those aren't done before a firmware gets released, there can be mishaps. I mean, we've seen it a ton in the industry. And, luckily, it's been better on the sanitize and the secure side of things than other hiccups we've seen, but that doesn't mean that it's 100%.
And so when we start talking about, you mentioned NIST earlier on, NIST 888 from 2014 as guidelines for sanitization, and the more recent IEEE 2883, which is a standard for sanitization. They rely on commands from a logical perspective being sent to drive firmware to enact the sanitization technique, which they're prescribing we should follow. In my opinion, as a layperson, they're pretty good, those specifications. Are they the best that we can look to right now today, in your opinion?
Yeah, I mean, as of right now, obviously that's the standard that we're all adhering to, and it's the best that we have. One of the things that we had spoken about before is, what drive manufacturers have to go through, right?
Yep.
They should be held to the same standard as the software that needs to erase them. They should be going through protocol level testing, making sure that the firmware that they're using or putting out does exactly what it says it does, especially when it comes to the sanitization part. Because if any data is left, then we're all open to these kinds of attacks by cyber terrorists, by anyone looking to, for malicious intent with our data, which is unfortunately rampant, right? I mean,
yep.
One of the things, another dirty little secret, I had traveled to the T10 committee meeting to present a new command spec called Exposed Flash in 2016. And this was when SSDs were really taking off. NVMe technology was just on the cusp of becoming, more mainstream. And I told them we need to be able to see the wear level space on the media, which is the space that is used to make sure that we're not wearing out each block and they're logical blocks, but each logical block and memory space and memory page on these devices, and that extends their life. So this space exists. So you might have a 1 terabyte NVMe or SSD. It might be 1.2 or 1.3 terabytes. And that 0.2 or 0.3, you don't get to see, but it gets swapped in and out. And so when it gets swapped in and out, we still need to be able to look at that. So I brought this command there and said, I want to be able to do this. This is why. And unfortunately, the reaction I got from the group, which by the way is supposed to be neutral, was, well, that's going to hurt our bottom line. We don't want that. And that was a problem for me. And they immediately shut it down and said, you can't talk that way in this session. That's not what this is. But that actually kind of spoke to the truth of people don't want reuse that make these products.
And I think where we are today, not only just from technology, but I guess societal as well, is that we are looking to be more sustainable in everyday life. And when we're talking about technology, we want to promote reuse wherever possible. And this
Absolutely.
is where sort of pre-programmed obsolescence is an issue, and manufacturers changing even chargers just to be annoying for user devices. It seems to me that companies like yourself are at the forefront of overcoming some of the maybe conscious or unconscious barriers which some of the device manufacturers may be putting in place to stop those devices from being extended into their life number 2, 3, or even 4. What can we do? We're just winding up to the end of the 15 here, Roger. What can we do as technologists to try and overcome these issues? Because the dirty secret, I guess, is that software sanitization is subject to the firmware vagaries which exist, whether they're significant or insignificant as yet to be determined. But we need to overcome this because we want to be able to sanitize devices and be assured that it's taking place all of the time. So where can we go as a sector, and what can the ODMs do perhaps to help us overcome this problem?
Yeah, I mean, I would say that, you know, the OEMs out there, your Dells, Hitachi, all of the enterprise storage companies can certainly help affect this change. They're the ones that are, in general, holding the largest amount of user data, right? And that's in different facilities of different companies, but it's their storage holding that. And so, you know, holding their vendors, the Seagates, Western Digital, Samsungs, Toshibas, Fujitsu's, whoever's making these drives, SanDisks, whoever they're buying them from, to the standards that software companies like myself are having to adhere to by going through a process, a forensic process like ADISA, by showing that, yes, this firmware does exactly what we say it does. It's gone through the process. It's gone through a chip level or through a media level forensics analysis, and you know, it is completely been erased. There is no data retrievable. You can now put this in your product and feel confident that anytime this device needs to be removed from a data center, that it's been erased correctly because we've already done our due diligence.
And I'm going to just go over the 15 a little bit because I want to draw out a point that you've made there. And it's not about self-promotion for either company here, but I was really surprised, and I'm a new convert to this sort of level of knowledge, as you know, maybe only the last couple of years. I was quite surprised at what we see going on between software and drive. So when we do the testing, of which we've tested with EPS, you're looking at how the software behaves to drives that we know support some of these commands, and we introduce drives that don't support those commands, and you're seeing exactly what the software is doing. In some instances, and definitely not with your product, but in some instances, it's a little bit like, and I don't speak French, I know you do, Roger, but when you're taught to speak French, you do it parrot fashion. It's when somebody speaks back and you're not expecting that response that sends you away into a flurry of, I can't do this. And we were seeing some of this going on. The software was sending the command, the drive was reporting back something unexpected, and the software would just melt down. And I think this is where the maturity of the sanitization tool set is really, really important, because the one-time command being issued may be reasonably easy to do, but it's actually what happens when it isn't supported. What happens when something isn't as I'm expecting? How do I behave?
Yeah,
That's
absolutely.
where the quality kicks in for me.
Yeah, I mean, the decision tree when something is not supported is just as important as when it is. I mean, if you try to do a cryptographic erasure or you don't know how to even check if it's supported, then you don't know if you should try it, or if you should move on to a block erase, or if you need to drop to a clear, or if Opal is supported and you need to prompt for a PSID and do a revert using that technology. So it really just depends on the robustness of the solution. But I mean, everyone should be holding software companies to that standard, where they are intelligent enough to make the correct decision, understand the data coming back, and make the correct decision off that, and so on. And so they shouldn't be leaving that in the technician's hands or operator's hands. It should be something intelligent enough built into the software to accommodate any erasure method that's required.
And that's the point I'm going to finish on, because in the ITAD community, which this is aimed at, they really do want to predominantly press the button and fire and forget, and they want the intelligence to be in their software or their chosen software toolset. And of course, where we're concerned, that's critical, because we want the outcome, data sanitization, to be absolute. We don't want any ifs, that, whys, and buts, and I think that's really important. Roger, we have run over, but I'm going to say thank you so much, and thank you for agreeing to re-record this. The first one wouldn't have been great. It was good at the time in terms of what we were able to do with the issues that we're suffering, but this is going to be much better. So thank you very much for your time.
My pleasure, Steve. Thank you for having me.
Thank you very much, guys. If you're on the channel, because you'll be watching this, please subscribe. I sound like one of those YouTubers, because we are putting lots of content up, and you'll be able to re-listen to some of the content as and when it gets published. So thank you for your time, Roger. Enjoy your weekend.
Thanks, you too. Take care.